Welcome back, YouTubers. We are going to be doing the layout of the Arduino Nano now, so let's get into it. I found on the Arduino Nano website they have the dimensions, so this will help a lot in the position of the components. So let's use that. The other thing I found is the headers. The headers here are 254 millimeters, and the other thing is over here in the dimensions. This was done in 2020, November 19, 2020. What I see is everything is in millimeters. So because I don't see any legend here, so we have to go by millimeters. So let's get to it. Welcome back, YouTubers. We are laying out this board. Let me share some things that I found so far, so let's get to it. So as you know, this board was this is the Arduino Nano. So it's looking out. I place all the components, so it's looking out something like this now, right? So that's where we at now. What we didn't know. So I didn't know that this board was a 4-layer board, first of all. So to change that to a 4-layer board, so how did I find out it was a 4-layer board? I went to Eagle and this is Eagle, and then here was looking at the layers. So I see top, power, mid, and bottom. So that's how I find out. And so this is the board, right? So they did it. So, and then I say, okay, so they label layer in the middle power, mid, and bottom. So I say, okay, so I know this one and that one. The copper plane is tied to ground. And then this one, where it's, I went here, their info, click here, and then I see here, signal name 5 volts. Okay, so that was the first thing. And the second thing was this one, where this one's tied to. Mid, click, and that's tied to ground. And say okay. So the copper plane is tied to ground. Then next, and say okay, what about the other two? So I went there, select top only, select this, tied to ground. Okay, and I say, so I keep writing in my notebook, and then bottom, and then I say okay, check. So the polygon is solid, isolated, rank 1, ground, signal name ground. Okay, so I have everything I need to know. Okay, so then I went over here, edit, net classes. They have the default, which have all the nets, and then they have this USB, which has the USB-P and USB-N net. So I have to make that rules. This is the rules for that. So, and so I copy those rules. And what else? Oh, okay, so not to be, and then the other one was the via size. I didn't know what via size is this. So then what I did was put via, and I selected here 309. That didn't look like 7. But then, okay, maybe they pay a manufacturer, they can drill this. But if we making this for Oshpark, I think the minimum drill is 10. So I make a V at 10 for that. Okay, so that was something that I was looking at. And then, so that's for Eagle, right? That's their board. Now we're dealing with Kicad. So under Kicad, first thing, I create a net class called USB, and under USB it has the USB N and USB net. Okay, right. So that was one. The other one, minimum beer drill 10. I believe I had it at 12 before. So 10 is the minimum that Oshpark can make. That depends on the manufacturer. If I'm going to make it in the United States, so I use Oshpark. And okay, what else? Okay, under the VS, I make that one. I make the drill size 10, the size 20. That's with copper. And what else? I made a differential pair. I'm using a width 10.2. I went to GLPCB. They have a calculator there. That's how I got this number. And that's the differential pair right here. Those two. In other softwares like pads layout, when you have a layer, like a layer here, like the mid layer, you can assign nets to that. But I couldn't find anything like that here. So what I've been doing is looking at, I got the Eagle here, I put in my other screen, you cannot see it, and I've been laying out. First I created a copper plate, so let's see. So let me show you. Take those out. So you go here, you see. So the copper plate, oh yeah, so the copper plate, this is green. So that's how it's looking now. And then green, yellow, and blue. Right? I was kind of matching their colors so I could follow easy. And the way I did it was I went in there over here. Let me put the mouse here. Let me put the highlight there. So here I click there and it says change color. And then I got this window here, right? And this is what I personally have in that window. But I didn't want to change the top. The ones that were interested was in the middle. So I went change color. And then here I match So they have red, green, blue, huge, and saturation. I got those numbers from the Eagle program. How did I get it? I went here. I went to this one here. Right click properties. And then I had this. Then I clicked there. And then I wrote these numbers here in my notebook. So the huge and the saturation, and then red, green, and blue. And then I did for that one and the mid and in the bottom. I did for all of them. I got those numbers here. I wrote it down and then once I was done with that, I moved this out of the way here. Then I went here and I put those numbers at here. Boom, 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 and then I click OK. And I did for that one, for this one, and for that one. Okay, so the other thing is, so because I'm going back and forth, and so I started with the power. Let me show you. So I started with power first. And I was getting like that and I didn't know. So you click here, rip, and then polygon, always a polygon, and then that takes that away. Then click info. And I believe the grid, I change it to mils. Okay, I went here, click mils. Okay, so then it matches mine. Then I click here, info, click the net, and then that tells me that the width is 24. So I use something close to 24 in my. So let me show you here. So here you just do properties, right? So this is about 30, just close enough to 24. Okay. There was another thing here that didn't make sense to me. I tried to make it look like what they have in this area over here. You see where you have the cap? So let me show you here on top. Okay, so I was looking at this and I put the bottom. Let's put all the layers. So over here you see you have the cap, and then here that's supposed to be a standoff, right? And it's between the cap. The cap is on the top, but the other component is on the bottom, but it's right in between those two. And I couldn't make it fit in my components. You could see, so it was much bigger. So then I went to the footprint, the local footprint, and I changed the size so I made it fit between the cap. And then I was able to follow that. Then I selected, I started routing here. I select the layer, track, and then I went from here to here, and then I place a via, and then to the top. Right. Then I looked at what they did over here. Then over here they going from this pin B in, going through the bottom layer to the power layer, and then they come all the way down here, and then it drops here and drops there. Okay, so like I said, I've been going back and forth looking at how they did it, and it's a good way to see what they were trying to do. The other thing is the silk screen, it's too big here. You don't want to see it, you just click that and take it away, then you can see easier. The other thing it's annoying is the fab, so I take that away, and I just try to leave the silk screen on so I can see where are the components. But I have to make it smaller. I started to do it. I probably can show you here. I don't know if you could see it, but right there, it's within the component. All right, so then I looked at it and I tried to emulate what they had, right? So it went from this layer, bottom layer, so I selected bottom layer first, then I pressed the via, and then from the via I press the other layer, and then I went follow that just like they did. And so that's for the setup. I'm forgetting something here. Okay, how do you change to 4 layers? 4 layers, you go here, layers, and then here you pick 4, and I saw that they're using they call this power layer, so I put power, and this is signal. All the power, the 5 volts and the 3 volts are going through here, so I leave it like that. And so then I try this yellow over here, the reset. You know, you need at least a 1 via to, so I tried to follow what they had here. Oh. Let's look at this here. Went to here, took that one out, that one out, that one out. Okay. Then I looked at it, the reset. It comes down here, goes like that, comes through here, then it's jumping into a pin here. So maybe I would put the top so you can see that. It comes here, can read, but it says reset. It drops here and then it goes into the top. And then it continues. But that's kind of what I did here. So you see, I came down here, come here, I just drop. Put the copper layer and I drop to reset. Okay, so I have at least one point in every plane, and for every plane, they add fill zones or copper planes. I assign it to each one. So this one, let's take the other three. We just need this one. So select. Okay, so as you can see, I put it on 5, like what they had. I put 5, and everybody else was grounded, right? I did one for each. And then you could see maybe take the edge. So okay, so it looks like I don't have a copper plane for the top. So let's make it. Select that one. The edge cuts. So okay, so so all of them have power planes, and to get it out. So that's what I'm doing right now, and so that's what I have for now. I'll continue routing. This is going to take a while, so I'll stop. So this is, I just want to give you information of what I found so far, and you know what the challenges looking ahead. But I'm using, like I said, I'm using the Eagle layout and looking at how can I emulate what they did, and hopefully we get there. And trying to understand, you know, and at the same time we're doing a 4-layer board, which is good. In the past, I've been doing only a 2-layer boards, so I didn't have any problems. But 4-layer, I done it in the past. I use pads and pad software to do that, XDesigner and all that, and Altium. But I don't have any of those softwares because they're expensive and I cannot afford it. So I use KiCad and Eagle for now, and it's all for learning purposes. You know what I'm trying to emulate and looking at the issues. You know, like I'm looking at the board, like this copper pads here look smaller in their design. I don't know why. It doesn't make sense because if you're trying to repair, maybe what is in mind is just, you know, buy a new one or something. But when you're trying to repair something that you make, you know, it's better to have longer pads access to be able to fix it. Here, maybe I could show you. Okay, here you can see the silk screen. I tried to make it smaller so it fits in there. Because when it's big like that, you cannot read it, and when you're laying out, it's kind of confusing. But that takes time, and so that's all I have, and let's stop that for now. Thank you for watching.